Hello and welcome to Chapter 8. We're going to talk about lists in this chapter. Up to now we've been talking about algorithms. Algorithms are the concept in computer science of using the programming language to express the steps that you want the computer to go through to solve the problem. Read some data, convert it to a floating point number, check to see if it's greater than 40, do one thing if it's greater than 40, do another thing if it's not, then print out the result. Or open a file, read everything. If the first line starts with something, do something. If not, skip it, and then add all the things up. Those are steps. Those are a series of steps, and hopefully by now you're getting to the point where you have a good understanding of steps. But there's a whole other side of computer programming, and we call it data structures. And data structures is not the steps, but instead clever ways that you lay out the data, and clever ways that you make sure that the data does what you want it to do. And so that's what we're going to start talking about now. Lists are the first and the simplest data structure. Strings are kind of like data structures, but lists are probably our first real data structure that we're going to think about and design and make use of effectively. But before we talk about what is a collection, we should talk about what is not a collection. So we're familiar with what a variable is. We know that a variable is a little piece of memory that's got a label on it. And then an assignment statement, sticks a 2 into X, and then 2 is in this little cupboard, and then it goes to the next line, and then 4 goes into X, and so the 2 goes away and the 4 is there. Now, a key thing is you can't have more than one variable at any given moment, right? And more than one value in a variable. So when we move to collections, collections are more like suitcases. We can put lots of things in them. We have ways of organizing them, and as we go through lists and dictionaries and tuples, we'll see how there are different ways to organize them. And as a matter of fact, we've been talking about lists for a while. Every time we use one of these square bracket syntaxes in earlier programs, we've been working with lists. And so this is technically a 3-item list with 3 strings, got commas here. Joseph is one string, Glenn and Sally are another string. And here's another one that is another thing. And the list is basically, it's a list constant, and it's being assigned into a variable. So this friends variable has 3 things in it. So that's different than what we've been talking about before. So these bracket structures with square brackets are those lists. And so the print is just a print with parentheses to get the print to work. But 12476 is a 3-item integer list. Red, yellow, and blue is a 3-item string list. But it doesn't all have to be integers or strings. Python can handle different things and different kinds of data in different positions in the list. So red, 2498.6, a 3-item list with a string, an integer, and a floating point number. And while we're not going to use this too much for now, this outer list is a 3-item list, and the second item is another list. So this is kind of alluding toward what we'll do when we start talking about data structures, and that is we have a structure and then we have another structure inside of it, and sometimes this can get quite complex. And we're doing this for a reason. This here has no reason, just to show you that it's possible that lists can be made up of lots of things, including other lists. And of course there is also the notion of the empty list. And like I said, I have had to be able to tell you about lists all along. We use them in for loops. We can put lots of things here. We can put file handle here, we can go through the file, we can put a string there, we can go through the characters in the string, and in a list. And the iteration variable then goes through the successive elements of the list, and that's why this prints off y4, 3, 2, 1, and then the loop is done and it prints out blast off. So we've been using them, and we've been actually iterating through lists with for statements all along. So the for statement has been something we use with lists, and when you just need to go iterate through the list and go through every item in order, the for is a great way to do that. So friend is our iteration variable, friends is our list variable, and so that says friend is going to successfully take on the value Joseph, Glenn, and Sally and print out, Happy New Year, Joseph, Glenn, and Sally. It runs 3 times, once for each of the values, and the iteration variable advances. Now, I do want to make it really clear that the choice of friends and friend singular and plural is arbitrary and capricious. It happens to be convenient and intuitive that the iteration variable is 1 and the list variable is more than 1. But Python has no idea about singular and plural. As a matter of fact, Python would care. It would be totally equivalent for Python to do the same thing, to have the list variable be z and the iteration variable be x. X will take on the successive values of these 3 things. Now, Am I being nice to you by calling this list friends and this iteration variable friend? I am, but I also don't want it to confuse you if you're just a beginning developer. So, just like strings, we can sort of look within lists. Part of the thing is when you put more than one thing in a data structure, you need to get them out. And so lists have positions, they maintain order, and so the first thing in the list is the sub-zero position, sub-1, sub-2. Just like strings, they're zero-based, just like European elevators, they're zero-based. So if we take a look and we say, oh, friend sub-1, that's how I read that, the little square brackets. When you take a variable here and you say friend sub-1. Remember, singular and plural don't matter. Friend sub-1 means Glenn, because this is the 0 and that's the 1, and then Sally's the sub-2, and so that's what prints Glenn out in this particular thing. Now, lists are mutable. Mutable is another word for changeable. They can be changed, meaning that a list has three things. You can change this thing right in the middle if you want. To take a look at what's not mutable, strings are not mutable. So if I take a look at assigning banana into fruit, well, fruit sub-0 is a capital letter B. Could we imagine for the moment that we could change fruit sub-0 to lowercase b? Well, the syntax would be how you would do it if you could do it, but it turns out that strings are not mutable, meaning they're not changeable once you create them. And that's why when we do things like lowercase or uppercase, we take a look at the fruit and we say, give me a lowercase copy of that, and then we take the return value from this and we store that in x, and that's how x becomes a lowercase banana. But fruit is still the original one, so fruit has not changed. Compare and contrast that with a list though. Here we have a 5-item list, 2, 14, 26, 41, and we're going to do the sub-2 position, and the sub-2 is 0, 1, 2, so that's that one right there, and we're going to assign a 28 into it. So that 28 is going in here, going to wipe that out and put 28 in. So we can do item assignment in lists by putting a bracket syntax on the left-hand side to say, don't just put it in the variable, put it in this position within the variable. So that's what that's doing, and when you print that out, the 28. Everything else is unchanged, meaning the whole list is there. There could be 1,000 items in the list, and then you're changing the second one. We have a function called len. We've been using this len function all along to take a look at how long strings are. It counts the number of characters in the string, so that's a 9-character string. If we have items in a list, len tells us how many items there are. It's not like how many characters there are, it's the number of things. And each thing doesn't have to be a number. It could be a number, a string, or even another list. And len is the way to say, hey, how many things are in there? There's a function that returns a list of numbers, and we use it, as we'll see in a second, to construct specialized loops to go through lists. So let's take a look at this range function just for a minute. So range takes as its parameter the number of numbers that you want returned. So I'd like a 4-item list with the numbers 0 up to but not including 4. And so it just turns out that that is really useful for constructing for loops that are counted for loops that go to 0 to the 1 to the 2, as compared to the the definite loops that go each way, go through each one. And so it's a common thing to say, okay, we know how many things are in this list. There are 3 friends, and if I combine range and len, so I take len friends, which is 3, and then I take range sub 3, I get 0, 1, and 2. And so the interesting thing is this 0 corresponds to the first one, 1 corresponds to the second one, and 2 corresponds to the third one. Okay? And so we'll use this to construct loops, especially when we need to go through an array and remember what position we're at. And so here's just an example of 2 different loops. This is a for loop that's just going to go through whatever's in this list. So friend is just going to take on the successive values, and so it's going to print out these 3 things just as you would expect. And if you don't need to, while you're going through the loop, know the position, your relative position from the top in the loop, that's okay. But sometimes you want a little more sophisticated loop, and instead you want to be able to loop through where you know the position. And so what we do instead is, instead of looping through the list itself, we do range len friends, which gives us 0, 1, 2, and then I takes on the successive values 0, 1, and then 2. So this loop is going to run 4 times, and I is 0 the first time. And we might even just look up the value inside that sub-zero value, so we get Joseph the first time, so prints out Happy New Year Joseph, goes and I becomes 1 now, and so it gives us Glenn, and that prints out, and away you go. So if you look at these two loops, they really do the exact same thing. The only difference is this we allowed the for to find its way with the iteration variable through, and here we created our own I variable that went through the positions, and they're dense, there's no gaps in here, so it's 0 through 2 that it goes through. So these two are equivalent. There will be times when you'll want to use one in the other. I tend to prefer the first one because it's prettier as long as it works for me. So that gets us started with loops. We'll be back in just a bit.